Houston, again, no problems. Today we are going to learn how to read, actually more like use, a topographic map. So again, let's do a little review. What does the contour interval mean? It is the difference in elevation. So if we're looking at this graph, or this map, it's not a graph, but here, come in, what are you thinking? Is that the dark lines, this is 5,700, this is 5,600. So the index contours, the dark ones, in this case, would be 100 feet. I'm making an assumption these are done in feet versus meters. And then the actual contour line is, there is 1, 2, 3, there's usually 4 or 5. I'm trying to find a place where I can count them more easily. 1, 2, is it just 3? No way. 1, 2, 3, 4, 5, 6. I bet it's 5. It's got to be 5. There's got to be 5 because 100 divided by 5 is a nice number, 20. I think we got 20-foot contour lines on this one, right? And again, we talked about this last time. Steep here because the lines are super duper close, and right over here, like crazy shallow, right? Because the index lines to go is at 20 feet. This is going from 20 feet from here to here, 20 feet from here to here, and it's, yeah, okay? So now let's talk about some interesting things that you often see. So sometimes what you'll do is, and you're looking at a contour map, you're going to see lines that go on the inside. You see this right here? So these are contour lines, but this would be a depression. It means that it's going down. Usually when we have a circle like this would be like climbing a hill. So if I was to go back to this graph, I don't see if we see like this right here, see how this right here, this spot right here, this would be the top of a mountain. It's getting steeper and steeper and steeper, right? So this is 5,800, 6,000, 61, and so right here we would have like a little hill, right? The top of a hill is where that would be. But if we go back to this one, since the lines are inside, this would be like an indentation in the land, right? This would be, could be a caldera of a volcano where it would be a low spot as you're climbing a mountain. Now this chart, I guess you would call it, this chart, by the way, of all the different symbols is reprinted in your book, because as you look at it, a topographic map, and you're going to do lots of looking at topographic maps, you're going to want to say, well, is this a lake, is this whatever, you know, etc. So this will be helpful. I'm not going to go through any details, but interesting things like airports, windmills, state boundary, woodland, etc., etc. So let's talk about how you can determine the direction of the flow of a river. So here we are at Baldy Mountain and Ute Creek, okay. And this is a very mountainous region, and we can see the blue line, and you probably realize the blue line is a creek. This is water. But the question is the river flowing as pictured here from the left to the right, or from the right to the left? Now, one thing we know is that, of course, water flows where? Downhill, down. So it's going to go downhill, but and I can look at the numbers. This is 10,400 feet. And if we find further into the right, we want to find another number here. I see a number 10,000. So right here is 10,000 feet, and here's 10,400 feet. So obviously this is going downhill. Now, one thing I was able to do is I was able to look at this and realize it was downhill left to right, as in downhill in this direction in this creek, because of the way it's the map is shaped. So you're going to get this as you figure this out. But if you get the contour intervals, hopefully you can see this, it's like you've got like V's. Do you see how there's sort of a V always in these like this? Do you see? The water is going to flow away from the V. This is the downhill. It's not going to flow the other direction. When you see this sort of a V pattern, do you see? It's very clear with this creek right here. Do you see? Let me change the color here. You can clearly see a V here, a V here, a V here, even a V here. It's kind of in that direction. So it's going to towards, if you think of this as like a Pokemon or whatever, no, what's a Pac-Man, Pokemon. It's going downhill away from the mouth, if you will, of the tiger, the Pokemon. It's moving in that direction, and that's how you can tell. Hello. things are falling in my room, if it's going downhill by just a really quick look, okay? Secondly, there's also, or nextly, or somethingly, you can also determine the scale of the map. So when they say here the scale of the map is 1 to 24,000, that means literally 24,000 times smaller than reality. But what's important here is these numbers here, right? This is miles, okay? And so from here to here would be 1 mile, from 0 to 1, right? And then this would be feet. So if I was to then, take a ruler, and I was going to say from the Market Street, this is a road, to here, I could take this, get a ruler, measure this distance, put that then, move it down, I've just moved it down to here, and I can say that that is probably a little bit more than a mile. And I can figure out exactly how far it is. All right, so that's the scale. Now don't get the scale confused with the contour interval. Remember, that is lines of the same elevation. All right, so a lot of interesting things here. This is the map accuracy. This is done by the U.S. Geological Survey, and they've even got latitude and longitude, so you can know exactly where on the Earth this map is. So let's just kind of summarize. How do you read these maps? First thing, determine the contour interval. All right, the contour interval, right, that's the change in elevation between each contour line. You're going to use the contour index contours to figure that out. Then you're going to determine the map scale, usually going to be at the bottom, identify hills and depressions, right, and use the legend to identify man-made features such as highways, railroads, and buildings. Jot this down. That will help you as you do these map activities. So let's take a look. All right, look for areas where the contour lines are close together. Where's the steep parts? Again, maybe this is repetitive. Cliff here, big cliff here. You see that? And this whole area right here is a cliff because they're super close together. And where are they spread apart? Okay, shallow, steep, and up in this area, this is going to be an interesting looking map because it's going to have like cones. That's a pretty fun one, okay? So it's going to be like a mountain. I'll see if I can draw what it would really look like from our perspective. It'd be super steep, This is going to be a volcano, right? I'm trying to draw it. It's going to be kind of really steep in certain spots and then shallow, and it's actually going to descend in this way. You're actually going to do some activities where you're going to convert this into the actual profile of a mountain and what it would look like. Hey guys, this is it for Topographic Maps. Just these 2 short videos that are going to help you to read the maps, because what we want to do is you're not going to, I can talk about it all day long, but you're going to learn this by doing it. And so we got map activities galore for you. Isn't that awesome? See you in class. It's early in the morning and I'm weird today. I don't know. See you in class.